Hello, ladies and gentlemen. It's Matifaru here again. Welcome back to my space. In this video, which is the second video on the playlist where we talk about how to avoid the use of the L'Hopital's rule in the evaluation of some limits, we are going to look at the second question on the problem set. In the previous video, we already saw how we successfully avoided the use of the L'Hopital's rule in evaluating this particular limit. Now we want to see how we can do that again with the second problem on the problem set. Without wasting much of our time, let's get right into it. Yeah, so the question is for us to evaluate the limit 1 plus cos x over x minus pi all squared as x approaches pi. So before we start doing all of that, let us recall some of the tools we have in our toolbox. So we have the even and the odd functions, the sine function being an odd function and the cosine function being an even function. Then we also have the facts, the working facts that we are dealing with, that the limit of sine x over x as x approaches 0 is equal to 1. Then we have the periodic properties of the sine and the cosine function, that sine of x plus any multiple of 2 pi is the same thing as sine x. Similarly, cosine of x plus any multiple of 2 pi is the same thing as cos pi. If we put that together with the other property that we have here, we can come up with one important identity that we need in this question. And that is the fact that sine x minus pi is the same thing as sine 2 pi plus x minus pi. And that is the same thing as sine x plus pi or pi plus x. And so using what we have in the first item here, that will give us minus 1 raised to power k of sine x, and that is equal to minus sine x. So in other words, a new identity that we need here is that sine x minus pi is equal to negative of sine x. Now we can get right into the business. So for us to solve or to evaluate this limit, first and foremost, if we check direct substitution, we see that this is 1 plus cosine of pi over pi minus pi squared. And this is 1 plus minus 1, since the cosine of pi is negative 1, over 0 squared, and that is 1 minus 1 over 0, which is an abomination. So it means we need to do something else. This is an indeterminate form. We cannot factorize, we cannot rationalize, since it is not a radical. So, and we want to avoid the use of L'Hopital's rule or the use of the series expansion. So one of the trick in our bag is to multiply by the conjugate of the trigonometric identity. So therefore we have this is equal to the limit as x approaches pi of 1 plus cos pi over x minus pi squared. So we multiply both the numerator and denominator by 1 minus cosine of x all over 1 minus cosine of x. And the numerator is a difference of 2 squares, so we get x approaches pi, so that is 1 squared minus cos x squared all over x minus pi squared times 1 minus cos x. And as usual, when we have cases of multiplying by conjugates, the only place where we need to expand things out or to simplify things is a place where we have the difference of 2 squares. So in this case, the denominator will leave it as it is while we express we simplify the numerator. So in this case, we have limit as x tends to pi of 1 minus cos squared x over x minus pi squared times 1 minus cos x. And the numerator is something we've seen before, which is one of the identities, the Pythagorean identity. So if sine squared theta plus cos squared theta equals to 1, then it means that sine squared theta is 1 minus cos squared theta. That means this is the same thing as the limit as x tends to pi of sine squared x over x minus pi squared. I can break this down as 1 over 1 minus cos x. Fine. And again, this can be split into two limits, the product of two limits. So this is limit as x approaches pi of sine squared x over x minus pi squared, then times the limit as x approaches pi of 1 over 1 minus cos x. The one on the right is already settled because when we substitute pi, we get a reasonable number. The one on the left, when we still put in pi, we'll get 0 over 0. So that is where the next manipulation will come in. And that is why I had to do this. You remember our fact, the limit of sine x over x as x approaches 0 is equal to 1. So the general thing is that what we have as the argument of the sine and the denominator must be the same thing. So here, using the fact that limit past power, we can say this is equal to the limit of sine x as x approaches pi over x minus pi squared. So what we have done is we have used this fact. Let me put this underneath. So we have used the fact that the limit of f of x raised to power n as x approaches a is the same thing as the limit of f of x as x approaches a raised to power n. That is another fact. So we've used that for the square expression here, and this is times 1, or the limit as x approaches pi of 1 over 1 minus cos x. Now, this does not look exactly like the fact. So we can see that in our fact, x approaches 0, and we have the same thing in the for sine and the denominator. So the manipulation is to make this thing look exactly like our fact. So what we're going to do, using what we proved at the beginning, that sine negative of sine x is equals to sine x minus pi. I know that sine x is equal to minus s minus sine x minus pi, from what we got here. So it means I can rewrite this as the limit as x approaches pi of negative of sine x minus pi over x minus pi squared times the limit as x approaches pi of 1 over 1 minus cos x. So knowing that, we can now say let y be equal to x minus pi. Why are we doing that? So that it can look exactly as the facts that we're using. So if y is equals to x minus pi, then we know that the limit will become negative of sine y over y. And as x approaches pi, so as x approaches pi, y will approach 0. So because that will be pi minus pi, which is 0, y will approach 0. So it means we're going to have y approach 0 here. So as a matter of fact, I can pull out the negative sign out of the limit so that we get something nice like this. So in this case, when we square this, then on the other side we have times the limit as x approaches pi of 1 over 1 minus cos x. And finally, we can say that this is equal to 1. So that means we're left with negative 1 squared times 1 over 1 minus cos pi. And we know that cos pi is negative 1. So this is 1 times 1 over 1 minus negative 1. That is 1 over 1 plus 1, which is equal to 1 over 2. In other words, the limit as x approaches pi, of 1 plus cos x over x minus pi squared is equal to 1 over 2. And that is the answer to the limit problem without using the L'Hopital's rule. If you have any question or any comment or reservations about what we've done in this video, kindly drop your comments in the comment section. Until we meet again in the next video, stay mathematically alert. Bye for now.